going on, everybody? This is Joshua Duran. Today I'm going to be talking to you about main sequence stars. I'm going to be talking about the life cycle of a star from its inception until its eventual demise, in which we are all going to die horrible deaths. So what we have is a molecular cloud which is mostly hydrogen, and it isn't until the molecular cloud comes into contact with another molecular cloud, or the solar wind from another star, or even the energy from a supernova, that it begins to collapse into itself. So this dense cloud starts to collapse into a protostar. Now, this protostar will keep collapsing until its temperatures reach over 10 million degrees. At this point, hydrogen fusion begins, which is the beginning of a main sequence star. So now that there's hydrogen fusion happening at the core, it becomes a main sequence star. It'll stay here for the longest point in its life. Eventually the fuel will run out, causing it to collapse. But then it'll expand and cool, turning into a red giant. Excuse the red supergiant, I made a mistake. Now the luminosity will shoot up, as well as the temperatures on Earth. So what happens now is that the core doesn't collapse due to the fact that there's electron pressure happening inside of it. The core gets heavier and hotter, reaching temperatures of 100 million degrees Celsius. At that point, helium fusion begins. So after the red giant, we're introduced to the yellow giant. Now this star will last about 100 million years. Its luminosity drops off, as well as its size, and the core will run out of helium. The next stage after this is the red supergiant. Now the red supergiant will have a carbon core. Eventually, that carbon core is going to push all of the material away from it, causing a planetary nebula, which you see here. After all of that planetary mass is pushed away by the nebula, it becomes a white dwarf.